Today we're going to explore the logarithm function y equals log base 3 of x. Let's start by writing out our function. Before we graph this function, let's understand what a logarithm means. The logarithm base 3 of x equals y means that 3 raised to the y power equals x. Let's create a coordinate system and graph this function. We'll use a scale that shows both positive and negative values on both axes. Let's plot some key points to help us sketch the graph. When x is 1, y is 0 because 3 to the 0 power is 1. When x is 3, y is 1 because 3 to the first power is 3. When x is 9, y is 2 because 3 squared is 9. Now, let's connect these points with a smooth curve. The logarithm function has a very distinctive shape. It starts at x equals 0 and increases slowly, curving upward. Let's discuss some important properties of this function. First, the domain. The logarithm is only defined for positive x values, so the domain is all numbers greater than 0. As x approaches 0, the function goes down without bound, creating a vertical asymptote at x equals 0. The range of this function is all real numbers. As x gets larger and larger, y increases very slowly, and as x approaches 0, y becomes more and more negative. Some other important properties. The function is always increasing, which means as x increases, y also increases. It passes through the point 1, 0, which we call the y-intercept of the exponential function y equals 3 to the x. To evaluate any logarithm with base 3, we can think about what power we need to raise 3 to in order to get our input value. For example, log base 3 of 27 equals 3 because 3 cubed equals 27. Let's summarize the key features of log base 3 of x. It's defined only for positive x values, has a vertical asymptote at x equals 0, is always increasing, and has a range of all real numbers.